It is my pleasure to introduce Dr. Sohee Park. She is faculty in the Department of Psychology at Vanderbilt University. And as a psychologist and a neuroscientist with a multicultural perspective, the goal of her work is to specify core components of behaviors that constitute psychosis and to implement targeted, non-invasive interventions to improve the quality of life in individuals with psychotic conditions and their families. Over the past 2 decades, her lab has studied mechanisms that underlie anomalous cognitive, affective, and social behavior in the psychosis spectrum conditions to enhance identification of endophenotypic markers for psychosis. Her early work uncovered the central importance of working memory impairments in all aspects of schizophrenia, from premorbid to chronic stages. More recently, her lab is focused on parsing the social brain networks in schizophrenia to identify the loci of problems that can be targeted for treatment. The complexities inherent in this work necessitate translational and interdisciplinary approaches. And her dynamic network of collaborative teams that include clinicians and engineers. They utilize diverse technologies and methods from cognitive psychology, social psychology, neuroimaging, brain stimulation, and physiology-based virtual reality technology. Dr. Park received her BA in Natural Science Tripos from the University of Cambridge and a PhD in psychology from Harvard. After completing a postdoctoral fellowship at the University Hospital of Zurich in Switzerland, she returned to the US to build her clinical neuroscience laboratory, first at Northwestern University and later at Vanderbilt University, where she holds the Gertrude Conway Vanderbilt Chair of Psychology. She has held visiting fellowships and faculty positions in Europe and in Asia, and worked diligently to maintain networks of collaborations across the US, Asia, and Australia that is really so critical for the type of work that we're trying to do with psychotic disorders and mental disorders in general. Dr. Park currently serves on editorial boards of Schizophrenia Research, Schizophrenia Bulletin, and Psychiatric Investigation, and chairs the Early Career Award Committee for the Society for Research on Psychopathology. In the past, she has served on the editorial boards of Psychological Science, Journal of Abnormal Psychology, and the Journal of Experimental Psychology. For SIRS and International Congress of Schizophrenia Research, she has worked for the education and program committees and mentorship programs. So please join me in welcoming Dr. Park.
Thank you. Thank you very much for the introduction. I'd like to thank the program chairs, Paula Dazan and Raquel Gore, for inviting me and the rest of the program committee. And of course, all of you for being here this Saturday morning. It's sunny shining outside. There's a beautiful swimming pool, so thank you very much. I'd like to begin by actually acknowledging the work done by current and former students and collaborators in my lab. They're all here. I can't read all of them, but thank you very much. Okay. All right. I'd like to begin by crediting my mentor, Phil Holzman. His influence is felt here, where he used to be a regular member, and his commitment to parse surface behavior into components, functional components that can be analyzed further in the brain and targeted for treatment. So that's his approach. But importantly, he never forgot the person inside who is trapped in the diagnosis. So in this lecture, I'll describe a series of behavioral studies. I'm not going to have a single brain picture. Behavioral studies that my lab has conducted in the past decade in an attempt to understand schizophrenia from the inside. And I hope to show how behavioral sciences might be able to contribute and to partner with the exciting emerging areas of all the omics and big data. Okay, I have no disclosure. First, I want to do this with you. It will take 30 seconds. Close your eyes, all of you. Don't fall asleep. Point to where you are. Where is self? Just point yourself. All right. Okay. How many people pointed to his or her chest or heart area? About half of you. How many people point to the head? It's 50 and 50. So some of you are heart people, some of you are brain people. How many people did this? Okay, that's very good. We're all here. So no matter where you do this, so who you do this with, there are two distinct regions that emerge. Where I am, that's usually upper part of the body, so either the face, head area, or the torso. And it is just plainly obvious that self is embodied. And we don't have to think about this. We're firmly inside our body. But this very simple, the state of being is not so simple as I found out. So why study self? It's sort of convoluted. So we take a lot of things for granted. For example, just being me, being in my body, and so on. I was trained as a cognitive psychologist. And for the first maybe 10 years of my career, my whole goal was showing that working memory deficit was the core of schizophrenia, and it could explain everything about schizophrenia. That was my aim. Then I took a sabbatical in 2006. I went to Prince of Wales Centre, run by Tim Crow at Oxford. I had planned to study laterality. Then I got derailed because in the seminar room at Prince of Wales Centre, I encountered this beautiful, powerful set of self-portraits done by an artist called Brian Chanley, who has schizophrenia. So in 1991, over the period of about 4 months, he painted himself and chronicled really what he was feeling, how he was feeling, his perceptions, his thoughts, and so on. So this is about a month into this project. He says, the person upstairs was reading my mind and speaking back to me to keep me in a sort of ego crucifixion. I felt this was because I was discharging very strong vibrations, which could easily be interpreted. The large rabbit ear is because I was confused and extremely sensitive to human voice. Oh, okay, here it is. About a month later, this is really how he sees himself. And you can see that his brain is now an enormous mouth acting independently of him. He says, I feel I'm always divided against myself by myself. And he talks about his social inaptitude, and this lack of social skills makes him a target, so he's paranoid. And then he says, I feel I'm giving off strong personality vibration. You can see those wavy lines, right? Hence the wavy lines emanating from my head, and so on. So this goes until July, and this is the last painting, last self-portrait that he left before he committed suicide. So here what you see is there's no self, no other, there's nothing. This is how he saw himself before he died, and this was his schizophrenia. Okay, so my goal as a cognitive psychologist was to develop objective, empirical, mechanistic model of schizophrenia. For example, we spent a long time developing oculomotor delayed response paradigm to study working memory that's parallel to what you do in non-human primates. Did brain imaging to show this was indeed what's going on in the brain. Tried to come up with models. So we were trying to understand schizophrenia as a biological disorder, but obviously it's not just part of the story. The real story is here in the person who has these subjective experiences, subjective internal phenomenological experiences, and that's the illness. And the connection between disorder and illness is not really well articulated in our field, but it's a connection we must make if we are to understand this condition and to develop treatments, intervention that makes sense to the person who experiences these things. All right, the idea that schizophrenia self-disorder obviously originated from Bloiler, who talked about fragmentation of self. And for him, he believed that the tearing apart or the splitting of the psychic function is a prominent symptom of the whole group. And he felt that dissociations were important. However, self-disorder is not an essential part of DSM criteria for schizophrenia. So how do we view schizophrenia? We think about positive symptoms such as hallucinations and delusions. We have negative symptoms, anhedonia, abolition, and so on. And we believe that there are underlying mechanisms that percolate up. So for example, deficit memory, attention, perception, so on, those percolate up to the surface to give us these symptoms. But none of these symptoms would really be a problem if they weren't distressing or caused difficulty relating self to other and causing social problems. So viewed in this way, the role of social cognition in understanding schizophrenia is rather large. So how do I understand you? How do we understand other people? So that's me. Well, I don't look like that, but that's self. And that's you, or lots of you, there. My brain processes social stimuli, and I have social brain network that includes frontal regions, inferior parietal lobule, temporal parietal junction, superior temporal gyrus, and so on. So I use these mechanisms to try to figure out what you are thinking, feeling, what your actions mean, and so on. I also try to simulate what you might be feeling or intending, thinking. So I share representation with you. And by doing that, you and I become we. And this is shared world. We share representations. We share a world. However, in schizophrenia, we believe that this shared world is broken. There's a disconnection between you and I here. All right. So it's important to understand social impairments in schizophrenia. It's also important to understand self-disturbances and relations between self and other. Fortunately for us, social impairments and social cognition perception research is quite advanced. So groups, for example, led by Raquel and Ruben Gore, Amy Pinkham, David Penn, and so on, they've made a huge progress in understanding social impairments. So what I'm going to focus mostly in this talk is talk about self-disturbance and relations between self and other. So how do we really even study self? Philosophers have it easy because they just have to talk about it and they don't have to prove anything, but we do. So this is one way of thinking. There are layers and layers of self, but I'm just presenting three here. There's social narrative self, which is about your identity, history, memory, and so on. You can study these using first-person accounts or autobiographical memory and so on. Then we have explicit self-awareness, as well as sort of internal minimal self. Some of these are kind of blurred into each other. In terms of agency and self-monitoring, there are really exquisite models that explain how agency disturbance arises. For example, corollary discharge or efference copy or forward model, in which assumption is that when I make a motor command, when I move my hand, for example, my motor systems activate so I can move my hand, but at the same time, an efference copy or corollary discharge is also made so that my brain knows I did it. Such model has been very successful explaining self-disturbance, self-monitoring, and agency. Okay, so I won't cover that. What I'm going to really try to focus on is a really sort of difficult middle inside part, minimal self. That's really hard to study. It's unconscious, implicit. It's about bodily self-awareness and embodiment. And it involves timing problems. So the fact that you are here and you think you're you, and that's just one of you, and you're so unitary and continuous over time, is an illusion, right? So we create this illusion, we're there, because we're physically like bound by our skin, we're held together by body, we're bound with working memory across time, and we're propelled into the future by mental representation of predictions. So we are held like that, and phenomenologists have suggested that temporal continuity is a property of the minimal self. So it's important. Okay. This is a model I adapted from Anil Seth's work. And here what he's doing is that he's saying that brain generates expectation, the mental representation of what you think would happen next. What would happen next? Okay, that's prediction. And then then we match, we see whether what we expected matches what actually happened. So we're doing chi-squared all the time in our lives. And if there is no gap, there's a match, then it's great, it's normal. Things go on as before. If there's a mismatch, though, there's a gap. And that spurs the brain to correct itself and do it again until there's no gap. So this is sort of the way it works, and it's very similar to what David Hemsley and Jeffrey Gray proposed a long time ago, and currently refined by Freston and Collette into a prediction model. Okay, what Seth is proposing is that we do this with all the system: exteroceptive, which is vision, audition, so sense from outside; proprioceptive, which involves muscles, joints and tension and movements; and interoceptive, which is very mysterious, a sense of the inside of the body. Okay, so we do all of that, and these three systems have to be integrated in time to give you the sense of bodily self. And if you have good bodily self, this is what you can do. That's very good bodily self. But in the case of schizophrenia, it is fragmented. There's a breakdown of time continuity. So it's not integrated, it's fragmented. And there's an inability to maintain mental representation over time. So I'm sneaking in working memory here. And there's a prediction difficulty. And the body signals from different modalities are not integrated, so the experience is discontinuous. It's difficult to have a unitary sense of self. Okay, so that was my brief intro. I'm going to describe pretty quickly, one after the other, experiments we've done to try to get at these. We'll start with more subjective, phenomenological aspect, moving on to spatial self, self-other transformation, embodiment, and then possible treatment. Okay. So we wanted to capture subjective experience of what our patients were telling us. But it was really difficult because what they were telling us don't really map onto anything much. So the idea is that experience of the body was not always stable and predictable, as Alice in Wonderland found out. And experience of self was not always stable and predictable either. So these are some of the things famous people with schizophrenia, but also our own participants told us. So Brian Chanley had said, "I feel I'm always divided against myself by myself." Ellen Sachs, this is about her book, really, The Center Cannot Hold. She says, "I was dissolving like a sandcastle with all the sand sliding away." So no self, blurring. The next one is from one of our patients. "I felt like an alien that was being used to manipulate humans by other aliens. It felt like someone was looking through my eyes without my consent." And he's a man who has frequent out-of-body experiences. "I sometimes feel like my hands are huge or my legs have gotten longer. I feel like I'm living someone else's memories. There were times long ago when I heard voices, but they were talking to me beside or behind my body. I feel disconnected from myself at times," which is similar to what Brian Chanley said, "that strange feeling, that out-of-body deal." Okay. So these things suggest that there's a really wide range of self-disturbances. So what we did a while ago was that we read all the first-person accounts published in Schizophrenia Bulletin from 1979 to 2012. And what we did was we met as a group at my lab, and we used perceptual aberration scale, which is a body aberration, and to score these first-person accounts to see if there are any perceptual aberrations. Remember, these essays were not about self-disturbance. They're just essays about what they were doing. It could even be about how they didn't like antipsychotic drugs. But when we did that, interestingly, 55% of these essays, we could find disturbances of body and self. There was a lot of reports of anomalous agency and self-awareness, and there was a lot of reports of social impairments, isolation, being lonely, and having no social skills. So this is a quote from Clara Keene. "I was unaware of my actions, observing myself in the third person, with the voices saying that I had lost myself." All right. So what we did was, instead of using self-report questionnaires or interviews such as EASE, because they were all verbal, and some of these things are not verbalizable. So we went another route. We got local artists, Megan Ichinose, who is sitting actually right here, and Baz Legley, who's my son. They drew pictures of drawings of self-disturbances, and we just used those as kind of stimuli to elicit these responses. So there are 21 pictures of self-disturbance, and 4 control pictures who are just normal bodily sensations, so itching, scratching, headache, and things like that. All right, And we look for presence, frequency of these experiences, distress, and how vivid these experiences were. So this is what it looks like. You'll see a picture, and it says, consider the picture below when I'm answering following questions. My soul sometimes leaves my body, and you have to yes or no, true, false, or not sure. Then it asks you about how often you have this experience. I don't know if you can read it, how often, how distressing this might be, how vivid it is, and then we ask you to write anything else. Do you have any comments? And it's just very simple. We just count up these points. And this is what it looks like. This is a participant with schizophrenia. Question, my experience of time changes dramatically sometimes, and he says true, and he writes things so you can get really interesting insight out of it. So he has a lot of these experiences. Okay. So when we do that, not surprising that people with schizophrenia score very high compared to controls, as you can see in this graph. Red schizophrenia, blue controls. Total score is much higher. Frequency, distress, vividness, all very high. But on the control items such as itching, stomachache, those things, there's not really a difference. Okay. And interestingly, those prodromal people here in pink, high-risk people, they score in between low risk and people with schizophrenia. We call this inventory body. Body was correlated with dissociative experience scale, perceptual aberration, not surprising, positive symptoms, and loneliness. I keep saying loneliness, I hope you remember that because it comes back at the end. It was not related to negative symptoms, no medication dose, and it was stable across 1.5 years, 18 months, so it's fairly stable. All right, so what does that mean? So these subjective experiences seem to be about unstable, unpredictable mental representation of self. There's an aspect of signal loss, a noisy signal. The body feels disconnected or unfamiliar, or body comes apart or dissolves. That's one aspect. Second aspect is spatial self-disturbance. Self is often not in the body. Okay, so in this thing you can see, so this is your physical body. This is what we call parasomatic body. So often self is not in the physical body, the parasomatic, and it can go back and forth. There's a lot of autoscopic experience. Autoscopic mean basically a hallucination about self, and whole body or body parts change. And third aspect is that of temporal discontinuity. There's fragmentation of time. All right, so we think this body is useful because it differentiates high-risk young people from low risk, and bodily self-disturbance plus social isolation might confer the risk. And secondly, it's picture-based. So self-disturbance being very difficult to verbalize, it somewhat gets around that problem, although it's still verbal in many ways. So it could be used with those reduced verbal ability and insight. It's available in different languages. All right, so what are some of the neurocognitive correlates of these experiences? When you think about it, this is all about visual imagery about the body. So it involves temporoparietal junction, for example, and a lot of parietal regions. And it involves proprioception and interoception mostly. Okay. So that's the subjective experience, but we need to go beyond self-reports and phenomenology. So we need to measure bodily self-disturbance without asking people. How do we do that? So first thing we did was we decided to measure spatial self and really try to explore what is meant by porous or weakened bodily self-boundary. So one dimension is whether you breach the body boundary. Do you leave your body? So it's the inside versus outside, and that's dissociation. So when body is not self. Second thing is you're inside yourself, so you know where you are, but it's blurry. So your body parts change, your body parts grow or change in shape and so on. And the third thing is a space between me and you. So gradient of body space is called peripersonal space. So where do I actually end? Well, my physical body ends at my skin, but that's not what my receptive fields in my brain, that's not where they end. It actually extends much further. So space between self and other, that's what we're looking at. Okay, so boundary of self, we're going to look at that, discontinuous versus continuous. So first thing we did was we wanted to look at plasticity of body parts, which is somewhat easy to demonstrate using illusions. So the first thing we did was Pinocchio illusion. Pinocchio illusion is quite cute. to demonstrate. What you do is you have to blindfold the subject, and subject holds her nose like that, and you sit like that, and then we vibrate the muscle, biceps here. So what you're doing is that you're stimulating muscle spindle in the biceps that would normally be stimulated by the muscle stretching. But the thing is, you're holding your nose, right? So what's happening is that it creates a kinesthetic illusion that the arm is moving away from the nose. But since your finger is fixed, you get this illusion that your nose is getting longer. So it's called Pinocchio illusion for that reason. And we measure this using 11-item probe, and we measure both physical sensations. That's a normal thing. Since we're vibrating your arm, you should feel vibration here. So we're asking those things. But also we're asking about body aberrations, strange sensations, and so on. So this involves proprioception, tactile perception. And to measure tactile perception, we also administer tactile sensitivity task. It's called 2-point sensitivity task. You have to decide, you put 2 sharp points without piercing the skin on the participant hand, and participant decide whether they're 2 points or 1 point. Okay. When we do that, Pinocchio illusion, not surprised, people with schizophrenia had huge Pinocchio illusion. Nose was growing longer, bigger, all kinds of stuff. They also had tactile sensitivity deficit. They had reduced tactile accuracy. And Pinocchio illusion was correlated with reduced tactile accuracy, increased experience of out-of-body experience, and also increased score on that body inventory that I showed you just before. It was correlated with positive symptoms and loneliness. So loneliness crops up here again. We then conducted this experiment with healthy undergraduates here and replicated the study. So here I actually separated the physical, the normal sensations of vibration and so on, and perceptual aberration aspect. And there's a big difference between the high risk and low risk group, high risk in dark blue and low risk in light blue, and perceptual aberration, but not in physical sensations. So if Pinocchio illusion is increased in high risk group, they're not ill, they're just prodromal, and decreased tactile sensitivity, and is correlated with positive schizotypy and loneliness. Again, okay. So just to recap Pinocchio results, there was unpredictable body boundary in schizophrenia. It was very easy to illustrate that things are changing in this population, the change in size and shape. And the subject experience was quite interesting. Some people felt that the body part was actually disconnected. Some people reported feeling of temperature change in the nose. And some people reported sensation on stimulated parts. So we're stimulating here and they're feeling stimulation on the other arm, so on. Okay, why? According to STAS model, interoceptive, proprioceptive, exteroceptive input and output are not coordinated, and this would be a multisensory problem. Okay, so that's the body parts change easily in the schizophrenia spectrum. And the question is, then, does that mean your peripersonal space is really ill-defined? So where do you end and where do I begin? That's the question, right? So this is peripersonal space is where I interact with objects and people, and I'm sure all of you who flew here in economy had that experience of peripersonal space being invaded by a person next to you. I had that. Okay, so what is peripersonal space? It's a space for distinguishing self and other. It allows me to prepare to either avoid you or approach you. It depends on the social context. So it depends on presence of others and that types of interaction, whether it's a threat-based or intimate, for example. Okay. In the non-human primates, it's really well worked out. So this is a work by Margarita and Iriki, and where they looked at receptive field properties following tool use. So before the tool use here, that's the monkey, they're recording from really from neurons, about visual receptive fields of neurons representing the hand and arm. So I can't really, somehow it doesn't show. But anyway, on the left side is a before tool use. Maybe I have to do that. Brain, and then after tool use, you can see, because he's been using the tool, the receptive field of that neuron has expanded hugely. So peripersonal space is very plastic, and after you stop using the tool, it goes back. In humans, you can't do that. So we have virtual reality experiments. This was developed by Serino et al. at École Polytechnique in Lausanne. And here is a very simple idea. What happens is that it's done usually in virtual reality. So you wear goggles and you'll see an object approach you, like a ball being thrown at you. So while this ball is coming towards you, you'll wear this trigger. You'll sense tactile vibration on your finger. When you feel this tactile vibration, you have to click the trigger and we measure that reaction time. So it's a tactile reaction time. However, it's a multisensory thing because the property of a peripersonal space is such that when something enters your peripersonal space, then your reaction time to the tactile vibration becomes very fast. So there's a big drop there. So that's the clue. When something enters your peripersonal space, the tactile reaction time becomes really fast. So you're going to see that. So we tried, so this is a diagram that's other throwing something at you wearing goggle. Sorry, I can't really make this work here, but anyway, you can see that he's throwing the ball. I'll show you two again, and then tactile vibration. And then you can plot a function to find where this reaction time drops very fast. So you can find the point where it changes most rapidly. And that gives you a sense of where peripersonal space would be for you. And then you can plot this reaction time graph and find a slope where that's a reaction time change occurs very rapidly. And that slope will give you a sense of range, space in which this self-other distinction is quite difficult for you. So that's two things going on here. So I'll show you this is what it looks like. So this is a non-social peripersonal space experiment where a tennis ball machine throws a ball at you. So this is what it will look like. That's you. Ooh, it enters it. Okay. This is a social condition where a man, we just had a man throwing, not both men and women. So man throws a tennis ball at you, and here it is. He's throwing. So that's social condition. All right. So we estimated peripersonal space using this paradigm. When we looked at non-social peripersonal space, there was no real difference between controls and schizophrenia patients in the slope. But when we looked at social peripersonal space, there was a big difference between people with schizophrenia controls in the shallowness of the slope. So what that means is that the shallowness of the slope, what it's indicating is that there is a larger space, longer space, extended space in which for you it's difficult to distinguish you and the other. Okay, so it's blurry. So peripersonal space for social interaction is altered in schizophrenia. There's prolonged gradient to PPS for social condition, in which self-other distinction is uncertain in that space. For non-social stimuli, it doesn't do much of a difference. So there seems to be there's a self-other distinction in that space. Now, within the space, we know that those people have a lot of out-of-body experiences. Maybe there's self-other transformation going on there. So how do we measure self-other transformation, and what is self-other transformation? It is like putting ourselves in other shoes, and we do this all the time because if you like movies, if you like Harry Potter or books, if you like playing virtual reality games, all of those involve you transforming yourself into other. So these are self-other transformation in everyday life, and we can do this. We are simulating being someone else, and we enjoy that greatly. All right, and that brings us perspective taking. This is a quote from Harper Lee. You never really understand a person until you consider things from his point of view, until you climb into skin and walk around in it. So it's really imagining what it's like to somebody else. This forms the basis of theory of mind. Well, how do we do it, though? How do we do this? Because we do this quite readily and easily. It involves, again, mental imagery and simulation. So mentally stepping into shoes of another person is really about mental representation and imagery. It's about internal simulation. We can model thoughts, emotions, and intentions of others. And we bring back parietal cortex here. Parietal cortex involved in mental imagery and self-processing. So Fuller Torrey, as well as Cindy Weibel, have written really comprehensive review papers on this. So parietal cortical abnormalities overlap with symptoms of schizophrenia, especially self-aberration. And this really is about mental imagery processing. So we asked the question, is mental imagery processing impaired in people with schizophrenia? We went back to the classic mental rotation paradigm of Cooper and Shepard from 1970s, in which it's a very easy task. So you had shown letter in present a mirror reverse or normal orientation. You can see that on the top left is a normal orientation, and on the other side is a mirror reverse. And you are asked to indicate orientation. Is the normal orientation or mirror reverse? That's all you have to do. When you do that, you can generate this nice curve. It's very reliable. Angle of rotation is plotted on the x-axis, and reaction time to indicate whether it's mirror reversed or not on the y-axis. And you see that you get slower and slower as you rotate it like this. And it's exactly like perception. So greater angle means longer reaction time, and imagery is just like perception. It takes longer to rotate this in your hand, and the same within your mind. When we did this experiment with people with schizophrenia, interestingly, on the right side is reaction time curve. It's basically it's really not different between patients and controls. It's the same. What's interesting is this error rate. When you look at this curve, what you'll notice is that people with, I can't really point, people with schizophrenia are making fewer errors at the most difficult condition, which is 180 degrees. They are outperforming. They're doing much better than controls. So there's enhancement here. So you might say, okay, so that's just, okay, they're doing better, but those are just letters and numbers. What has that got to do with self-other transformation? Well, you can then do rotation with people, not real people, but pictures of people. So here, this is egocentric rotation experiment. Here, what you have to decide is that, okay, on the left side, he's back-facing, so he's not facing you. So I'm asking you, is it his left hand or right hand? Answer? Left, yes. And the other side is Phil has now turned around. Is that his left hand or right hand? Yeah, it's left. But you are slower on the second case because front-facing stimulus is more difficult because you actually have to rotate yourself into him, whereas in the back-facing, you just walked into him. So it takes actually longer to do egocentric rotation if he's front-facing. Most social interaction occurs with front-facing people. Okay, all right. When you do this, people with schizophrenia have absolutely perfect egocentric rotation. They're intact. There's no difference between controls and patients with schizophrenia on this one. They're not better, but it's fine. However, what's interesting is that when you look at healthy people and look at their schizotypal traits, schizotypy, what we found was that there's a really nice correlation between the high schizotypy, positive syndrome scale, and ability to do this. So those high in positive syndrome schizotypy did much better on this task. So there's an enhancement in the schizophrenia spectrum. All right, so with respect to self-other transformation, there's evidence of enhanced visual imagery. We've conducted many other experiments in mental rotation. Whatever we do, they show enhancement. So the imagery generation, inspection, rotation, and so on, people with schizophrenia do better than control subjects. High schizotypy goes with increased self-other transformation, but excessive self-other transformation is not good for you because you should be in your body most of the time, not in someone else's body. So this brings us to the area of anomalous self-other distinction. Being someone else is good for reading books or trying to understand someone else or watching a movie. And we use enhanced imagery and perspective taking really support this process. The fact that we can map our self-other body space is related to also empathy. And increased self-to-other transformation, again, helps with theory of mind. However, if you have excess amount of this, it's not good for you because it increases likelihood that body is not in the self. We knew that out-of-body experience was increased in schizophrenia. We've had patients who had this actually in the lab. But we didn't know how prevalent this experience was. How prevalent is it? It turns out that people are general public is interested in out-of-body because if you go to Amazon, you can buy thousands of books that tells you step-by-step guide to out-of-body experience. And there are conferences dedicated to this. They're usually called astral projection conference. So when you think about it, personal accounts of supernatural experiences are common everywhere. We all have supernatural accounts in our cultures, and that involve astral projection as well as near-death experience. So how common is out-of-body experience? There's not much data, but Ohioan found that in UK, between 6 to 14% of the population say they've had something like out-of-body. Gallup poll says about 5% of US adults. So it's, it's pretty large because probably some people don't admit this. Okay, so the question was, is it a factor for psychosis? So we just like in Nashville, which is a pretty normal city actually, we wanted to find out how many people have out-of-body experience. What we found was that about 40% of people diagnosed with schizophrenia, as well as high-risk undergraduates, so those are prodromal undergraduates, had experienced out-of-body experience, whereas low-risk controls didn't. Now, 20% may seem really high. It's because we didn't screen for drugs or anything. It was just anybody. So if you take out those who use drugs and had that other maybe neurological disorder, it does go down to about 8% in the end. But this low-risk group includes, we didn't screen for drugs at all. So what we're seeing is the out-of-body experience associated with, the other thing was loneliness again, okay. Out-of-body experience was correlated with loneliness regardless of diagnosis, okay. So if you're lonely, you're more likely to have this thing. So again, message is social isolation, self-disturbance might be prodromal sign. Okay, so let's think about out-of-body experience. Here's me. When I'm having an out-of-body experience, I am disconnected from me. Now, I am also disconnected from other if I have schizophrenia, right? So it's a double, really, it's not double, it is double dissociation in that sense, I guess. I am not inside me, and I'm not with you either. So it causes social isolation in double sense. So I want to talk about social disconnection, self-disturbance. And here I want to talk about late Ralph Hoffman's hypothesis called social deaffrontation hypothesis. Oh, there's a, sorry, typo. Social deaffrontation, okay. So what he said was analogous to physical deaffrontation and subsequent reorganization of the brain, for example, phantom limb syndrome, which is common after amputation. So your leg is gone, but you're feeling that sensation. So it's called phantom limb. The reason is that when something is cut, the brain reorganizes to compensate, so you're feeling that. He said it was same with humans and society. When social contacts are removed, there is an increased mental social activity, the increased activation of social cognition network. And you can see that in sensory deprivation studies, for example, but also in solitary confinement in prisons. When you put in this solitary confinement, people start to hallucinate. And another case would be Robinson Crusoe and his man Friday. You're alone, you create the other. So that's his idea. Social isolation generates hallucinations and delusions. So, oh, sorry, I keep misspelling social deaffrontation. Okay, social isolation could lead to overcompensation and hypermentalizing, so generates social delusions. And then our own twist in this, that loneliness will exacerbate hallucinations and delusions. So I sort of just brief side thing. I want to talk about social versus non-social. What is social to me may not be social to you, for example. What is social? For example, Ellen Sachs in her book says houses talk to her when she walked home from school. Houses are inanimate things. They don't talk, but they talk to her. They were alive. Mark Vonnegut, who had psychosis, at some point he becomes anorexic. He cannot eat anything because plants begin to talk to him, and he cannot bear to kill plants and eat the plants. So what's happening is that world that was non-social previous becomes social in that case. So what is social depends on your culture, your age, your condition, religion, and all kinds of stuff. But in all of those things, social isolation drives social delusions. So I want to show you the saddest experiment psychologists have ever done. and it's the famous Harlow's experiment conducted in Wisconsin, University of Wisconsin, where he took baby monkey away from the mother and reared the baby in these cages with right temperature and right amount of nutrition. He had two things, a wire mother who gave the milk and a terry cloth mother who was soft. And the baby would nurse from the wire mother, but would go and cuddle the terry cloth mother. So these babies never grow up to be normal. They have permanent social problems, anxiety, and lots of other things. So early social isolation, deprivation causes lasting damage to the brain, and the baby will never be normal in society. Now, what I thought was happening here is that baby has nobody, no social contact. So what she has done is create the mother, create the other, because she doesn't have mother or another person. So again, so we want to look at loneliness and self-disturbance. First thing is, are people lonely? It turns out people with schizophrenia are much more lonely than people who don't have schizophrenia, and that's not very surprising. When you split people with schizophrenia, those with out-of-body experience, those without out-of-body experience, there's a difference. People with OBE are much more lonely than schizophrenic patients without OBE. Okay. All right. So summary so far is that we have observed out-of-body experience about 40% of patients in prodromal controls. It's about 20% in controls if you don't screen for drug use. If you screen for that, it goes back down to about 8% in low-risk group. The dissociative experience correlate with schizotypy, and presence of out-of-body experience is correlated with increased social isolation regardless of diagnosis. So social isolation, abnormal somatosensory experience may be really important prodromal signs. And social disconnection also affects what's inside you. Manos Zakiri's group has done really interesting study looking at interoceptive accuracy following social exclusion. It's a very mild social exclusion. They have people come into the lab and make them play something called cyberball game. Cyberball game is a simple video game where you're supposed to toss ball at each other, but you're excluded. And then, so that's a very mild social exclusion. I mean, it really doesn't mean much. But even that mild manipulation resulted in reduced heartbeat detection accuracy, which correlates with interoception. So there's decreased embodied mechanism or impaired mechanism after social disconnection. And Cassiope show that there's interpersonal synchrony and mimicry is affected by loneliness. Okay, so we wanted to look at what's inside. What are feelings like inside? So people worked on it mostly at Lenny Torregrossa from the poster session, Matthew Snodgrass, Justin Hong, and Unzol Chan, who is in Justin's poster. Okay, so interoception schizophrenia spectrum. We know that there's a reduction in interoceptive awareness, for example, through heartbeat detection task. We also know that there's disconnection of internal states from awareness. For example, if you show patients with schizophrenia very disturbing emotional pictures of amputation or just nasty stuff, for example, or something very arousing, there's a discrepancy between their self-reported arousal and actual psychophysiological indices of arousal, such as galvanic skin response. Okay. So there's disconnection. Secondly, there's increased alexithymia in schizophrenia population. Alexithymia is inability to verbalize your emotions. Okay. So mental representation of interoception is an important area to study. So we want to really map emotions in the body. And luckily for us, Larry Numenma and Turco had invented a method called M-Body. It's really nice and easy method done on the computer. So you're shown outlines, 2 outlines of human body, and you get a word, an emotion was sadness. And on the left body, I ask you to paint all the areas inside that body outline where you feel becoming more active or more energetic and so on. So that's activation map. On the right side, I ask you to color in the regions where you feel weaker, less active, less energetic. So when you do that, we can generate this maps of activation, deactivation, and to generate finally the combination map. When you do that in healthy college students, we replicated Lowry's data in Nashville. What you see is that emotions are mapped differently in the body, and so topography of emotion is different depending on different emotion, and they look different. For example, when you look at disgust, it looks very different from sadness, right? So we have these fingerprints, body prints, I guess, of emotion, and then our bodies know what it is. Now, Lenny looked at bodily maps of emotions in controls and people with schizophrenia, and that's what it looks like. It just got published in Schizophrenia Bulletin. So when you look at a schizophrenia map, what do you see? It's different, right? What you see here is a couple of things. One is that different emotions are not differentiated, right? They're very similar. There's some different spatial distribution of sensation. For example, when you look at depression, sorry, I'll go back there again. Depression is here, next to contempt. If you can, here, 1, 2, 3, 4, 5, fifth from the right. In healthy controls, it's all blue, it's deactivated all over. You feel weak and not energetic. In the case of schizophrenia, some deactivation, but the head is bright red. So activation in the head is very different. What we think is that awareness of bodily sensations during an emotional experience involves attention to your interoceptive signals, but it also involves ability to recall and simulate those sensations as well. So it involves, again, memory, representation, and imagery. So to summarize so far, bodily self-aberration schizophrenia involves self-body dissociation, flexible body boundary, and extended peripersonal space. Topography of emotions, the feelings are blurred and altered. There's embodiment difficulties, and there's problems in interoception, proprioception, exteroception. And we think that this, a lot of it really bears to the idea there's increased internal neural noise, and there's definitely a timing problem. So how do we treat this? So let's move to treatment. Can we change our bodily self? Can we do this? I'm sure we can. There's two different methods. One is doing the top-down, such as cognitive behavior therapy or meditation. You can do that. And that's difficult. It takes a long time, and so on. What we did was something, what I think of as more bottom-up, change your body. Psychiatrists such as Frank Ruricht in London have done body psychotherapy, which is sort of a hybrid, it's both bottom-up and top-down. Peter Falka in Munich, they've been doing physical exercise to train the body with great outcome. And you can also train multisensory integration. And you can do a hybrid version where you simulate. So we tried two different things. One is, the question is, can training change your bodily self? And so we looked at the case of actually athletes to look at effect of proprioceptive and interoceptive training. And secondly, we developed a social simulation game in virtual reality. So let me show you emotion embodiment in athletes. So we recruited competitive swimmers, whole body athletes. They practice 20 plus hours a week and more. They're acutely aware of the conditions of their bodies. And we compare them to healthy controls matched in age, schizotypal traits, education, and gender. So we did the same in-body experiment. So these are the control maps. So you've seen that before. And this is the athlete. And the difference may not seem actually obvious. It's not going to leap out, but I'll do this. What we found is this. The maps of athletes are spatially roughly the same as maps of controls, but they're much more precise. They're very precise. So this is an example of love. Love felt by an athlete and love felt by a non-athlete. The difference is that basically athletes are much more precise in where they're feeling love. So there's an increase in accuracy and precision in those who train proprioceptively, interoceptively. Okay, so let's move on to the last part of simulation-based training. I kept on mentioning simulation all the time. Can we train simulation? In video games, you can. So we developed novel virtual reality social skills training program for schizophrenia because simulation is important for all interpersonal interactions and learning. So all forms of learning and skill acquisition depend on mental simulation and adaptive rehearsal across multiple contexts. When you learn any sports, music, language, dance, social, any of these things, you have to simulate and practice first. That's what we are doing. And virtual reality happens to offer the ideal rehearsal space where you can practice in a realistic way. So it works like this. We had scenarios. Participants explore virtual environments such as cafeteria, and they have to find out some personal information from an avatar that you don't know. You've never met this person. For example, find out her birthday. So when you meet somebody for the first time, you don't go say, hi, when's your birthday? That's bad social skill. So that's what we're trying to do. We're trying to really train people to make small talk. Okay. Participant must select avatar to approach, interact with, for example, bus stop. And then once you select the avatar, there's a green goo on avatar's face. And what you need to do is you must fixate your eyes, so this is done with eye tracker, on the avatar prior to initial conversations. You have to fixate on the green goo, and if you fixate, then green goo will go away, and you can finally see the avatar's face and interact with her. Okay. And the participant then will receive feedback after selecting a conversation topic and exchange information. I'll just show you briefly how it works. Can we have the video? Okay, so this is the bus stop. So you choose your mission. What do you want to work on? That's the avatar. Fix.
I like it most of the time because it makes it easy to get places.
Okay, you fixated.
Excellent choice. You correctly offered some information about yourself and met your goal of finding out if Avatar likes riding the bus.
Okay, so I'm going to move. Thank you. I can stop. Okay, so that's the idea. You do this with different scenarios. So after 10 sessions of this over 5 weeks, we saw really significant reduction in negative symptoms, actually, which is exciting because negative symptoms are very hard to budge. No change in positive symptoms and change in BPRS. Okay. And then there's social engagement latency, which is an index of social attention, also improved. So this is when you have to fixate on the avatar's face to start social interaction. So the shorter the reaction time, the better. That's decreased steadily through the 10 sessions. So when we did the simulation-based social skills training, negative symptoms improved, emotional recognition went up, social attention improved, and embodiment, we did body mapping before and after as well, that improved. So this is really not top-down effect, it's just bottom-up. There was excellent retention and acceptability, they loved it. And for example, we got comments like, I feel like the avatars were very friendly. So there are benefits to simulating social situation and practicing small talk. Okay. So I'll end with this kind of schema. We believe that anomalous bodily self-experiences lie at the core of schizophrenia, at least from the person who experiences it. There's aspect of perceptual incoherence and multisensory integration deficit. That's combined with enhanced mental imagery. Imagery actually is very good and maybe too good. There is interoceptive and proprioceptive deficit that lies on top of that. So those three things, perceptual incoherence, mental imagery enhancement, and proprioceptive deficit, those are about the participant, patient. But the last one, the social amputation, is really society. There's a big aspect of what we call social amputation that involves social isolation, social exclusion, social defeat, social deaffrontation. Those things interact over time to give you delusions. And when you have social delusions, you're going to be further isolated because you're acting strange now. So that it feeds into the whole bad cycle. So what I wanted to say here is this. Studying behavior can help us bridge the gap between the biological disorder of schizophrenia and the subjective personal illness, also called schizophrenia. And doing this, bridging the gap, will bring us closer to the more complete and complex picture of this condition. And such efforts could be integrated with the current efforts underway in genetic neuroimaging, for example, because you would have to know what the phenotype is, and the big data science and other efforts. So ultimately, what we hope to do really is bring the self back to the body. Okay, here it is. Thank you. Okay. Apparently we have time for questions. Easy questions, please.
I have one. Thank you very much for that really interesting presentation. I work with patients regularly, and much of what you said rang true. And it also, one of the things that I've been struck by in doing research with rating scales like the PANSS or the BPRS is how much they miss about what is really going on with psychosis. And some of the limitations in our studies and our study results, I think, stem from the imperfect measurements we're doing of the core pathology. So I was wondering, from all of the assessments you've done, which would you think would be most critical to incorporate into clinical trials where we're looking to improve outcomes for people with psychotic disorders?
I think if you were trained in something like EASE by Josep Panas and Louis Sass, that might be one thing, but it's quite difficult to really unwieldy to administer. So that's why we developed this body inventory with the pictures. There's also iPace developed by David Sisser in Hawaii, which is a self-report version of EASE. So you could use something like that. But I mean, of course, the body is not perfect. But I think it's a good beginning to just trigger these responses so you know they are having them and how often and how distressing. So I think that would be a step. But it's really open. I think other people should develop further and really refine these methods. But to do that, we really need to know the behavior and feelings and intentions. Yeah, okay. I don't know which Daniel or Angus?
Well, I have an easy question.
Okay, good. Which is?
So one of the most prevalent symptoms in psychosis is persecution. And persecution seems to be, in almost all cases, a remarkable failure to take on the perspective of the others. The other doesn't have largely a malevolent intention, and yet that is ascribed to them quite broadly and quite readily. How do you reconcile persecution within your framework?
So first is that I think persecution, that kind of paranoid delusion, is not really not having theory of mind of the other. You could frame it as having too many theories, right? So if you ask somebody who is really paranoid, why do you think he or she did this? They could come up with 15 theories or 100 theories when I can only come up with one. So in that way, they have much richer mental life. It's just they cannot choose which one. So that's so I think it's different from an autism where there is really no theory of mind. In a case with schizophrenia, it could be too many theories of mind that are just filling up your working memory capacity. So that's one thing. The other thing about paranoia is that when you think about peripersonal space, depending on how big this peripersonal space, how small, when something enters your peripersonal space, you're going to feel threatened if you're in kind of more anxious state. Since you have this extended range of peripersonal space, anything in that space is going to be kind of blurry. So that's another way to think about paranoia. So these are, I don't think I can answer your questions precisely because reconciliation or discrepant findings are difficult. But one way I would think about it is that I don't think paranoia is really persecution, delusion, and lack of theory of mind. I think it's too many theories of mind. And the other thing is that peripersonal space and all this self-other distinction being blurry or breached might cause a problem as well, because these are unsettling. Thank you.
Thank you for this really interesting presentation. You could argue that one disorder where social differentiation is very important is autism.
Yeah, yeah.
Well, they never become psychotic, or very rarely. And as far as I know, they also don't have disturbed bodily experiences. So how would you reconcile that with your theory?
I think they do. I'm collaborating with autism researcher called Carissa Cascio, and we've been collecting peripersonal space data in both autism and schizophrenia adults. So, and we published a position paper. It's the first author, so Jean-Paul Noël, and what we propose is that in people with autism, body boundary is in fact like too tight, whereas in schizophrenia is extended very much out. So they're on the opposite end of the spectrum, where people with autism don't get rubber hand illusion very easily. They never have out-of-body experience. And everything is on the opposite spectrum of, in a way, as far as body self is concerned. We have not done things like body and this phenomenological analysis with people with autism, but that would be really interesting to do, because we think that people with autism have impaired theory of mind because they don't really have one. But in case of schizophrenia, they have too many of those, too much theory of mind. So we're following that thought, but it really remains to be seen.
Okay.
Any other comments or questions? I want to thank Dr. Park very much. It was wonderful.
Thank you.